Hello, everyone. My name is Alicia Lucas, and I will be showcasing my work on improvement of spatial memory in fruit fly larvae. So regarding spatial memory, I do have a textbook definition in the upper left corner, but thinking about it in a real life setting, we use spatial memory almost every day. So for example, when we're going to school or work and we're starting to leave, we go to grab our keys. So that recollection of where we placed our keys, we can thank that due to spatial memory, or how we get to school or work, our drive there, or remembering the location of a room that we need to be in. So spatial memory does have a huge impact in our lives. Um, so we do understand the basic structures and processes that go into spatial memory. For example, one of the key structures in it is the hippocampus. And regarding processes, we go through encoding, storage, and retrieval. So when we're learning how to find the location of something, that's when we're encoding and we're forming this kind of mental map, or as I like to call it, like a GPS in our mind of how to get to somewhere. And then we store that for later use. So when a situation arises where we need to use that mental map, we can retrieve it and find the object or location we're looking for. So we do understand these ideas, but an idea arises about the brain in general, its ability to have plasticity, which means to form, well, to adapt and form new neural pathways. So with this in mind, I was motivated to find a way to improve spatial memory. If the brain can adapt, then it should be able to improve regarding this type of memory. So to test improvement of spatial memory, I decided to use fruit fly larvae as subjects. Fruit flies are great for testing because they share about 61% of genes with humans. They can form and learn, or they could form memories and learn, and they reproduce quickly. So that makes it convenient for testing. So regarding the experiment itself, I wanted to see the effects of positive reinforcement on spatial memory in fruit fly larvae. And from this, I formed hypotheses. So when introducing positive reinforcement continuously, the average time larvae take to reach the target should shorten. And when that reinforcement is removed, I expect that the times will remain similar. And these hypotheses can be supported by operant conditioning. So this is a type of learning where if given a negative reinforcement, something aversive, the behavior will decrease. And when given a positive reinforcement, the behavior will increase. So in this case, we're giving the positive reinforcement, which means behavior will go up and time should be going down. So regarding the experiment itself, to test this, I created a Y-shaped maze. So they would start at the beginning, they would go up, and they would either have to choose one direction or the other. And regarding the reinforcement, the positive reinforcement, I chose two different ones. So I had food covered in a banana scented molecule, and I also had diluted sugar water. So, and we ran 6 trials. So in trials 1 through 3, the positive reinforcement was the food, and in trials 4 through 6, the positive reinforcement was the sugar water. So in every single trial, there were 3 conditions. So we had one maze where there was no reinforcement, another where there was reinforcement on the left side, and another where there was reinforcement on the right side. So we would run these trials, these 6 trials, they would be 15 minutes each. And while the trials were going on, I would record how many larvae reached the target. And the ones that reached the target, I would record their times and take an average of those times. So after doing the trials with the reinforcement, I removed the reinforcement and ran another trial and gathered the same type of data. So when looking at the graphs, hopefully you guys can see my cursor. I have 2 graphs here in the middle, and this is with the food. And then these ones over here are with the sugar water and no reinforcement. So with all of these graphs, what we see is we see the same kinds of trends. So regarding the number of larvae that hit the target directly it kind of varies. It doesn't really go in an upward trend. However, the average time that larvae who made it to the target decreased. So we see these trends. So like right here, right here, right here. And regarding the reinforcement that was removed, it seems that the time remains similar, which is great. So we see over here, you know, or excuse me, over here, these two times, they're very, very similar to each other. And same with these. And well, with these ones over here, probably about like a minute difference. So that's good. So ultimately, from this data, we can see that spatial memory was impacted by positive reinforcement as the trials went on. There was improvement. And some larvae still went to that like trained side, even when the reinforcement was removed. So due to time constraints, what I would have done was more trials regarding the no reinforcement, because there is a kind of like a theory or general agreement about giving positive reinforcement every single time and then suddenly removing it. So when suddenly removing it, those times would remain similar, but over time, extinction would most likely happen and the times theoretically should start to go up. So to expand on the experiment, one should run more trials with the no reinforcement. Another thing to mention is an experimental flaw. So regarding the maze design, I filled the maze is up with this isoamyl acetate. So it's like a gel, right? And the problem is the gel shrinks. So what happened was some of the larvae would crawl on top of the maze instead of going through the pathways. So regarding future experiments, I would want to fill that all the way up so it would be a less likely chance that they would crawl on top of the maze and make the experiment a little bit more reliable. Regarding so while this experiment focused on the improvement of spatial memory, one could also expand and focus on factors that worsen it. For example, lithium and dopamine deficiencies in certain situations have been shown to cause like adverse cognitive effects. So one could run an experiment around those and look for new trends or new findings. So regarding the literature cited, I decided to put in a QR code. So if you guys have a smartphone, you could open up your camera app, point it at the QR code, and if you would like to see my cited sources, that's one way to do it. But overall, I just wanted to thank you guys for listening in. And if you have any questions, feel free to ask. So thank you.